Okay, we're gonna try this again. Third time's the charm, right? All right, first thing we're gonna wanna do is the daily questions. So go ahead and pause here so that you can get that done. Okay, so you're going to have your A value of 3, your B value of 2, and your X value should be X plus 1. You go ahead and put that all into the exponential form. So I'm going to have my B to the X equals A, and that would be your solution. If you haven't gotten out your notes already, go ahead and get your notes out so that we can get that going. And I keep checking to make sure it's recording because I don't want to do this a fourth time. Alrighty, so you should be on page 11. We are in 4.4, and I'm going to use my little pointer here so that I don't have to rewrite everything again. So E is a irrational number with an approximate value of 2.71828. And we usually use this for things like interest and exponential growth and exponential decay, which we'll get into tomorrow. E is also known as the natural number or natural base. And we write it as the f of x equals e to the x power. We also can do the opposite of an exponential function by using what is called the natural logarithm. And we do the same thing as a logarithm. We just write ln instead of log base e. That is the only difference. Otherwise, everything stays the same. I'm like paranoid that it's not going to record again. All right, so we are going to talk really quick about our exponential functions. So as a reminder, we have b to the x power equals a for an exponential function, and the logarithm function, which is the inverse or the opposite of a exponential function, is the log of base b of a equals x. But for a natural base function with that letter e, rather than writing e, we use the ln abbreviation, the natural log abbreviation, but a and x stay in the same place. We just don't write the log of base e, we just write natural log instead. So as an example here in number 1, my b value is e, my x value is x, and my a is 24. So I plug all of those things into my log function, and I get the log of b of a equals x. But instead of writing log e, we write it just as ln, or natural log. Or in number 2, we have the base is e, my exponent is 9, so x is 9, and then a is x. So I have the log base b of a equals x. But again, we don't write log base e, we write it just as the natural log ln. Go ahead and pause the video and try number 3. So for number 3, you should have gotten the natural log of 72. So that is my a value equals your x value of x plus 5. And we can go the other way as well. So we can go from the natural logarithm form to the exponential form. Anytime you have the natural log, it's always a base of e. So your b in both cases here are going to be e because you're using the natural log. So then my x value is 58, and then a is x, because remember it's log base b of a equals x, so those kind of switch. And then you just plug everything into the function, b to the x power equals a. Same idea then in number 5, you've got your base of e, A is 6 because it's base E of A equals x, which is just x here. And then put it into the function notation, b to the x equals a. Go ahead and again, pause the video and try number 6. All right, so for number 6, you're going to have b is e. Your x is going to be 32, and then your a is that x minus 9. Plug it all in, so you have b to the x power equals a. And we're not going to do that bottom portion, so you can go ahead and cross that out and then switch the page. So when we are going to be solving them, you're going to use Desmos. Just making sure we're recording still. Okay, we're going to be using Desmos. So in line 1 of Desmos, you're typing in the function that comes before the equal sign. Make sure you put y equals in there. And then after the equal sign, you're typing in everything else. So before the equal sign with a y, after the equal sign with a y. Make sure they're in 2 different lines, and then you just find where those 2 graphs intersect, and you're looking for the x value specifically, which is, in this case, 7. And if you were doing that, I'm going to give you a second so that you can type it all in. I should have prefaced that you need Desmos out. So I'll wait another second. So in case you didn't have Desmos out already, then you can grab it. You do the same thing. Make sure that whenever you are typing in your functions, you're exchanging any variables for x. There are cases where Desmos does not want to read a variable unless it is y or x. So make sure that you're using x inside and you're setting it equal to y and finding where they intersect, which in this case is 5. So then skipping down, we'll go to number 19. You're doing the same thing when you have the exponential version instead of the natural log. So type both of them into separate lines, and you should get 4.04. Giving you a second so that you can try it out. Or like in number 21, again, you are replacing any variable that isn't x with x so that you can type these into Desmos. Desmos doesn't like to read variables in some cases that are not y or x. Set them both equal to y. In both of these cases, you will need to zoom out. And you should get the x-intercept of these 2 graphs is 0.74. So you are going to be doing a hallway activity. There are 8 stations, and in each station you are doing 3 to 4 questions. I'm going to add a page in station 1. You are going to be finding the domain, the range, the end behavior, and the y-intercept and asymptote. Station 2. domain range, the x-intercept, and the asymptote. This is going to be a vertical asymptote. And your station 1 asymptote is a horizontal. Station 3, you're stating the transformations. Station 4, you're solving exponential equations. You're going to do that the same way in Desmos that we just did. Station 5, you are converting between logarithms and exponential forms. In station 6, you are evaluating some logarithms. You're just going to type those into Desmos and it will give you a value. Remember, the shift dash is what will give you your little subscript number. And then 7, you are solving for x, so you're going to do what you did in number 4, like we did in the notes today. And 8, you are doing the same thing. So 4, 7, and 8, all in Desmos, as well as station 6, and you're just finding a value. Remember, shift 6 will give you subscripts. And it gives you your little number. So if you want to pause the video so that you can have the directions on the board, all of the directions are also on the station cards out in the hallway. You're going to want to make sure that you get this done by the end of class.